Welcome back. Today we're going to talk about inverse functions and how to find them. We're going to look at a graphical approach and an algebraic approach. As we start off here, we need to kind of understand exactly what an inverse function is. An inverse function involves the interchange of the x and the y coordinates. Well, so you'll look here. If I have a function that's defined as x plus 4, my domain is going to be 1, 2, 3, 4. So as we add 4 to each of those, we end up with 1, 5, 2, 6, 3, 7, 4, 8. That means we added 4 to each of them. Well, the inverse is going to involve the switching of those. So as we look at the domain and the range being switched, the 0.51, 62, 73, and 84 are going to be in the inverse of x, and that's a notation that we're going to talk about here in just a second. As we look at finding inverse functions, we notice that there's a correlation, and we're going to talk about what that actually means. Finding the inverse of f of x equals 4x. Well, inverse functions, we can call them undo functions. That's a very rudimentary way to think about it. And so if I'm looking at f of x is equal to 4x, how do I undo it? Well, undoing 4x is undoing 4 times x. So the inverse, once again, we're going to talk about that in a minute, the minus 1, is going to be x over 4, like the opposite function, the undo function. How would we undo multiplying by 4? Well, it would be dividing by 4. And so as we look at this, the way to test is to put the inverse into the original function. Because if they're undo functions, when we put the original into, or the inverse into the original, we should just get x. If they are inverses. And so this is a way to check to see if we got them right. And so if I do this, 4x is the original, so f of x is equal to 4x is my original. So I'm going to put in the inverse. So I'm going to do f of f inverse of x. So that means I'm going to take my 4 and I'm going to put in x over 4. Well, 4 times x over 4 would cancel, and so that would be equal to just x. So these are inverses. So f of x equals 4x. F inverse of x is equal to x over 4. Those are inverses of one another, as we proved here with this little bit of math right here. Okay, and continue to look at inverse functions, we do need to know some notation. The inverse of x, so inverse is denoted by a -1 exponent. So f of x, the inverse is f -1 of x. So f -1 doesn't mean 1 over x, it means the inverse of f of x. So as we continue to look on, let's look at a couple of examples of graphing the inverse. Here I have 2 functions that are inverses. So what I'm telling you is this is f of x and this is the inverse of f of x. How we find those, we're going to find out in a minute. But graphically what we're looking at is I put them on there, the red one and the blue one, and what I want you to notice is they are reflections of one another. I'm going to use a black pen here. And this is y equals x. So inverses are reflections over y equals x. Okay? And so these 2 lines are inverses because they are reflections over y equals x. And so if I look at this point here, this is 2, 1. The reflection over y equals x, well, I'm going to go straight across at a 90-degree angle across this line, and 1, 2 is on there. So they interchange x and y coordinates. Okay, so if 2, 1 is on my original, then 1, 2 has to be on my inverse. Let's look at another one. This one I had to put a restriction on the domain because the domain has to be the same for both functions, but it works for the squared function. So the red one is my squared function, but it's just x greater than 0 because the domain of my inverse is, x has to be greater than 0, actually greater than or equal to 0. And so, as we look, notice what happens. These are reflections in y equals x. So this function has an inverse, and they are inverses of one another because they reflect over that line y equals x. So that's the basics of graphing these functions. Things we need to look for as we talk about inverse is whether or not it's possible. And so as we find inverses algebraically, you may want to pause and write this down, write this list down. But after you pause, just know that this is what we're talking about. First of all, we need to use the horizontal line test. We haven't talked about that yet. But the horizontal line test says this: a function has an inverse if and only if it passes the horizontal line test. So any horizontal line intersects f only one time. So much like the vertical line test, the horizontal line test just tests for having an inverse. So this is testing to have an inverse. So first of all, we're going to test using the horizontal line test to say, does it even have an inverse? And then what we're going to do is we're going to replace f of x with y. So instead of having f of x is equal to x squared, we're going to say y is equal to f of x, or y is equal to x squared. Then we're going to switch x and y, solve for y, and then replace y with f inverse of x, and show that when I do and undo, that I get x when I get done. That's a big long list of steps. We're going to use it in just 1 second to talk about this function and to do an example, but that's the list of steps. Make sure you write those down. Let's look at an example. In this case, I'm giving you this function, and the function is 5 minus 3x over 2. So f of x is equal to 5 minus 3x over 2. This is the graph. So this line is y equals 5 minus 3x over 2. So if I use the horizontal line test, any of these horizontal lines only intersect at once. And so it definitely has an inverse. So I did test it with the horizontal line test. So now what I'm going to do is go about the process of finding the inverse. And so I'm going to rewrite. So I'm going to say y equals 5 minus 3x over 2. So I rewrote, replacing f of x with y. And now I'm going to switch x and y. So now I'm going to say x equals 5 minus 3y over 2. So I'm just checking the steps off my list. Now I'm going to solve for y like I would with any sort of other equation. Multiply both sides by 2. So I have 2x equals 5 minus 3y. So I'll subtract 5. So I have 2x minus 5 equals negative 3y. And I'll divide by negative 3 on both sides. And so what I'm left with is I have negative 2x over 3 minus 5 over negative 3. So my negatives and positives got a little bit mixed up there, so let's rewrite a little bit. So what I can do is I can say, if I went back up here, a negative divided by a negative is a positive. So I could do it like this. 5, since I have a common denominator, minus 2x over 3 equals y. So I solved for y. And so now I need to do my proper notation. So I'm going to say f inverse of x equals 5 minus 2x over 3. And then to show that this is true, I would replace my x in this case with my original function. And what you'll see is that if you do that, that it does check out. Okay, so it does in fact equal x when you put it back in. And that's how that works. Okay, so that's us finding the inverse algebraically. It's not very complicated, but once you have that list of steps down, it'll be much, much easier. Okay, thanks for watching, guys, and we'll see you next time.